Alright, so we promised you we'd be back with another video about lossy compression, and here we are. Well, one of the major techniques used in compressing images and video is called chroma subsampling. Sounds pretty cool, huh? Well, it is, and it's not all that hard to understand either. So you're gonna want to stay right where you are. Okay, so just what is chroma subsampling? Well, as you might have guessed, it has something to do with the colors in an image. It's a technique that gets applied at the beginning of the compression process. But before that, you need to make sure you're using the right color model. Most images use what's called the RGB color model, where every color you see is made by mixing the three primary colors red, green, and blue. But this color space actually doesn't really work when it comes to chroma subsampling. What we need is a color space that's able to distinguish between the luma of an image, which represents the relative brightness of the image, and its chroma, or chrominance, which has to do with its color information. The most commonly used color model here is YCBCR. Y represents the image's luma component, its brightness. It records how bright or how white each pixel is, or how dark, that is, how black it is. This is why this component is also responsible for the sharpness of the image. The CB component tells us where a pixel lies on a scale between yellow and blue, and the CR component tells us where it is on a scale from red or from green. So what you need to remember is that chroma subsampling requires a color model that is able to distinguish between luma information and chroma information. Once we've got the right model though, we can get started. Okay, so first, let's have a look at the basic idea behind chroma subsampling. One thing about the human eye is that we're significantly better at picking up on differences in relative brightness than we are at perceiving color information. What that means is that while we're really quick to notice when something is lighter or darker, we're not as good as seeing what colors are present and in what ratio. And so the goal of chroma subsampling is to keep the luma component as consistent as possible while trying to lowball the color information, that is, the chroma components. And this works precisely because we humans aren't really that great at perceiving color information, and most of the time, we don't even realize if something's missing. This means that what we're trying to do is save space by recording the color information for fewer pixels. Alright, so how's this work? Well, in theory, chroma subsampling always involves a ratio between three different channels, which we'll go ahead and call A, B, and C. The first of these values, A, indicates the horizontal sampling reference, or the width of the block of pixels in question. Nowadays, the number in question is almost always going to be 4. B refers to the first row of pixels and C to the second one. What this means is that the whole picture is broken up into blocks of pixels 4 in width and 2 in height. The most important thing that A tells us is how many pixels in each block are going to be sampled for brightness. With each row being 4 across, that means we're going to be recording the luma values for 4 pixels in each row. Okay, now let's look at B. B tells us how many pixels in the first row we're going to be sampling the chroma information, CB and CR for. And hey, who'd have thought? C just says how many pixels in the second row we're going to sample the chroma information for. You know, CB and CR. So what you have to remember here is that in chroma subsampling, you're always going to be given 3 different values. A gives you the horizontal sampling reference, or width of the sample, and the number of luma pixels. B tells you the number of color pixels in the first row, and C gives you the number of color pixels in the second row. Let's go ahead and try and wrap our heads around all this a bit better by checking out a few typical configurations. In all these cases, our sample is going to be 2 pixels high and 4 pixels wide. So what happens when all values are set at 4? Then 4 pixels worth of luma information are going to be sampled for each row. And since B and C are also 4, we're actually going to be recording full CB and CR information for each pixel in the sample. And that's it. Now nothing's getting compressed here, since we're going to be sampling all the pixels. At the same time, of course, this also means the picture quality is going to be the highest. Another really common subsampling scheme is 4-2-2. This is what tends to be used on most color TVs. A stays the same with a value of 4, but now that we've got 2 for B, that means that in the first row, it's only going to be the chroma information in every other pixel that gets sampled. And since C is also 2, the same thing happens in row 2. Because the CB and CR values are only being taken from every other pixel, it's now possible to compress the image. JPEG files, among others, use a scheme of 420. So once again, the luma information for all 4 pixels is recorded, and the CB and CR values are taken for every other pixel in the first row. But in the second row, there's nothing going on in terms of chroma information. Now in real life, things are a bit more complicated with JPEGs. They just go and take a pixel from the middle of it all and sample the color. The resulting color block is then going to be 2 pixels high and 2 pixels wide. In terms of theory, however, everything we said before applies here as well. Older video formats sometimes use a 4-1-1 scheme. Once again, the luma values get sampled for all 4 pixels in each row. but the first row is only going to have chroma information for 1 pixel. The same goes for the second row, which is also going to have chroma information for a single pixel. And that's about it. Okay, so what do you guys need to take away from all this today? Chroma subsampling is a method used for compressing images. The first thing you want to do is make sure you have the right color model. Then you're going to save less chroma information than luma information for the pixels in the image. And that's how you get a smaller file size. Okay, so if you want to know more about the next couple of steps when it comes to lossy compression, just keep clicking on to the next few videos.